Hello, soon-to-be graduates. I am Doug Clark, Dean of the College of Chemistry, and it is my great pleasure to welcome all of you, your family, your relatives, your friends to the 2024 College of Chemistry Commencement Ceremony. This is a very exciting day, a momentous day, and this day belongs to you, the College of Chemistry class of 2024. I think you all owe yourselves another round of applause. So we have a great program in store for you this afternoon, so please be seated and let's begin. It is wonderful, as always, to see so many of you gathered to celebrate this joyous occasion and this very important milestone. To all of our graduates, the College of Chemistry, from where you are graduating, has a great and illustrious history, a history that is now 152 years old. Many of the most important discoveries in chemistry and in chemical engineering have been made right here at Berkeley. And many of the most influential members of the profession have passed through this college as undergraduates, graduate students, postdocs, and faculty. And indeed, many of the most important discoveries yet to be made in and outside of the laboratory will be made by you. You are graduating from the finest institution of its kind in the world. And you can look that up. As graduates of the College of Chemistry, you are now part of this distinguished and remarkable history. And you deserve to take great pride in your accomplishments and in your membership in the College of Chemistry community, especially given the unprecedented challenges you have all endured throughout your time here. Some of you may be walking across the stage with the diploma for the very first time, having missed out on your high school commencement ceremony in 2020. I hope this day is everything that you dreamed it would be. We, of course, all live in and share a chemical world. Our food and medicine, our energy and transportation, our local and global environment, our planet's changing climate, indeed, nearly everything we touch or rely on in our daily lives is impacted by chemists and chemical engineers. This is both a great opportunity and a great responsibility. As graduates of the College of Chemistry, you are empowered to help lead the way in developing sustainable and equitable solutions to many of the world's most pressing problems, and ensure that they be implemented in a socially responsible manner. You are, after all, not only graduates of the College of Chemistry, but of UC Berkeley, the finest public institution in the world. Or one might say the greatest university in the world. So the faculty of the College of Chemistry is pleased and proud to recognize all of you as you step forward to begin the next phase of your professional lives. Today, we honor 359 graduates of the 2023-24 academic year. Now, you may want to hold your applause. Here we go. 59 recipients of the Bachelor of Science in Chemistry, 63 recipients of the Bachelor of Science in Chemical Biology, this is going to be fun. 100 recipients of the Bachelor of Science in Chemical Engineering. That one's going to be tough to top. 3 recipients of the Bachelor of Arts in Chemistry, 3 recipients of the Master... I'll slow down. 3 recipients of the Master of Science in Chemistry. We're about a third of the way there. 2 recipients of the Master of Science in Chemical Engineering. 18 recipients of the Master of Science in Chemical Engineering's Product Development Program. 14 recipients of the Master of Science in Chemical Engineering's Bioprocess Engineering Program. 20 recipients of the Master of Science in Molecular Science and Software Engineering Program. 59 recipients of the PhD in Chemistry. And 18 recipients of the PhD in Chemical Engineering. My colleagues and I congratulate all of you. Okay, cue the applause. Very well done. All right, now on with the show. So since this ceremony honors the accomplishments of you, our students, it is most appropriate to hear first from your representative and classmate. This year's student speaker is Kiara Ning. Kiara is graduating this spring, having earned a Bachelor of Science degree in Chemistry and a Bachelor of Arts degree in Molecular and Cell Biology with a focus on neurobiology. Kiara's initial passion was for chemistry. She says that chemistry was the first subject she encountered that allowed her to continuously uncover more and more concepts to absorb and understand. And she was only held back by her own initiative and drive to learn. And her incredible drive is evident by her laudable resume of research projects, presentations, awards, and outreach activities. As if that weren't enough, after speeding through her chemistry coursework, Kiara decided, why not explore a little neuroscience as well? So this has come to present a difficult decision for Kiara. She is currently applying to MD PhD programs and will apply to chemistry PhD programs in the fall. As she waits to make the decision on her next phase in academia, she will be working in a research lab at the UCSF Weill Institute for Neurosciences as a full-time research assistant. Beyond that, Kiara sees herself as a practicing physician, leading her own lab in the design and execution of clinical studies for remyelination treatments in people with multiple sclerosis, or as a researcher in an inorganic synthetic chemistry laboratory involving the lanthanides and actinides. Knowing Kiara, she might just do both. Outside of the laboratory, Kiara loves archery, having been a member of the Cal archery team for the last 3 years. And she hopes to continue this hobby and become more involved in local and national archery events. She also plays the viola and tenor saxophone and plans on returning music to her extracurricular repertoire post-graduation. At Berkeley, Kiara's most important lesson learned was to not let opportunities pass you by, as she will touch on in her speech today. In my view, Kiara, you have certainly hit multiple bullseyes in turning a target range of opportunities into impressive achievements. So please join me in welcoming Kiara to the podium.
Good afternoon, esteemed faculty members, joyful families, and most importantly, the distinguished and dynamic class of 2024. Though the majority of you in all likelihood have been checked out up here since senior year began, I, for one, find it hard to believe the finality of it all. I still vividly recall those weeks where assignments, assessments, and obligations would happen all at once like some cruel, concerted mechanism. I thought, I'll attend my friend's next orchestra concert after I finish this lab report. I'll take the SF outing invitation next time after I've found a research group. I'll compete at nationals with Cal Archery next year when I don't have exams the week after. It was only when I dared to venture past my inert state did I truly start to thrive. In the crucible of those chaotic weeks, I discovered the power of growth and adaptation that catalyzed me to search for exciting new courses, stimulating projects, and now graduate programs full of promise of awaiting adventures and endeavors. These crucial, albeit intense, transition states I've experienced here at Berkeley truly embody the phrase I once heard Dean John Arnold describe the history of inorganic chemistry with: full of moments of serendipity. We as chemists don't have the luxury to wait for examinations to pass or deadlines to pass before we make our next move. We live in a world that is constantly being reshaped, redefined, disproved, and proved, and then disproved again. Yet despite that, each and every one of you have overcome the activation barrier needed to reach your own transition states, as evidence for you sitting here today. You have made it. After being broken and reformed by Berkeley's brutal organic chemistry series, after 2 semesters of waiting for the elevators and Latimer to be fixed and the fire alarms to stop going off every other day, after years of labs that resulted in heartbreaks and breakthroughs, successes and failures, you have made it. You have now reached your highest potential yet, and are now at the helm of your own destiny in determining what you will make of your life next as your final product. So in a sense, there's really not much finality at all about today. Some of you will go on to become the next Nobel Prize laureates or leading figures in industrial breakthroughs, contributing chemical discoveries the likes of which the world has never seen. Others of you will become teachers and mentors that will guide the next generation in challenging the impossible. Or maybe some of you would choose to leave the world of molecules behind entirely, only occasionally flexing your Berkeley College of Chemistry stamp of approval. Therefore, as monumental as this intermediate state is of finishing your undergraduate education, I believe that is even more paramount to acknowledge the infinite possibilities of what becomes of you next. As a parting thought, if there's anything that I have learned at this great bastion of education, it's that you'll be presented with opportunities, challenges, decisions, and often all at once. It's almost too easy to feel overwhelmed, to believe that we must wait for the perfect moment, the ideal circumstance, before taking action. But as chemists, we also understand that even in the most complex reactions, there is beauty to be found. For it's in the midst of this chaos that true growth occurs, where resilience is forged, and where the most remarkable discoveries are made. And with that, my heartiest congratulations to the class of 2024. May your futures be filled with endless discoveries, bold experiments, and the unwavering courage to embrace those moments of chaos, and with it, opportunity. Thank you.
Thank you, Kiara. At this time, I would like to turn the microphone over to this year's commencement speaker, retired U.S. Air Force General and College of Chemistry alumna Ellen Polakowski. In 1947, The chemical engineering program was formed at Berkeley, and by 1977, the undergraduate class contained 13% women. It was at that time that the first women doctoral students entered the program. The first 3 women in chemical engineering received doctoral degrees in 1980, and Ellen was the 4th in 1981. Ellen was in the ROTC program when she joined the lab of her PhD advisor, John Prausnitz. The only ROTC program at her high school was the Air Force, and that's how she was introduced to her eventual career. She says that at that time, the Air Force had the greatest number of opportunities for tech engineers, particularly women. While she only planned to be in service for a few years, she wound up in a much longer commitment as she enjoyed being part of something that influenced society on such a large scale. That opportunity led to a 40-year career in the Air Force, culminating with her becoming only the 3rd woman to achieve the rank of 4-star general in the U.S. Air Force. She went from being the manager of the service's airborne laser program to its chief buyer of space technology, to ending her career as the head of the Air Force Material Command before retiring. That command employs approximately 80,000 military and civilian personnel and represents over 30% of the total Air Force budget, and provides the Air Force with research and development, life cycle systems management, test and evaluation, installation support, depot maintenance, and supply chain management. As you can imagine, this command requires a specific expertise in the oversight of large organizations and technical programs, which Ellen is known for, as well as for her ability to lead organizations through change and successfully transitioning technology. Currently, Ellen is an independent corporate director providing knowledge on strategic planning, program management, logistics, and research and development. Do you know we're looking for a new dean, Ellen? Oh. Anyway, for her strong leadership skills and technical management acumen, Ellen has been recognized nationally with several honors and awards. Among these recognitions are the Women in Aerospace Lifetime Achievement Award, the National Defense Industrial Association's Peter B. Tietz Award, and the Air Force Association Executive Management Award. She is an honorary fellow of the American Institute of Aeronautics and Astronautics, a fellow of the Directed Energy Professional Society, and a member of the National Academy of Engineering. It is my honor to introduce her to all of you today. So please join me in welcoming Ellen Pawlikowski to the podium.
Go Bears. That's not the reaction I get when I teach at the University of Spoiled Children when I say that. First of all, let me say congratulations, graduates. I know we've said it once, but we can't say it enough. I want to thank Dean Clark for the invitation to participate in this commencement. I'm honored to be here and to be back on campus. But I also understand that the reason you, your family, and friends are here is to celebrate your accomplishments, not to listen to me. So I promise you that I won't make this one more Berkeley lecture, and I will be brief. It's hard for me to imagine that it has been 42 years since I was hooded. Literally, I have had a lifetime of experiences since I left the Berkeley campus. When I walked off campus in April of 1982, I could not have imagined that I would be returning to the campus as a commencement speaker. I was just a young engineer on a mission to bring technology to bear on solving the world's hardest problems. And I was kind of glad to leave because I had been sharing an apartment with 3 chemistry majors. And now you all know the Big Bang Theory television show, right? Well, I was the engineer who was reminded every day that I was not a scientist. But I got them back. I called them bottle washers. And they called me the plumber. The invitation to speak caused me to pause and reflect on what it was I wanted to share with you. I thought about what I learned from my years at Berkeley, because Berkeley is truly a unique campus that offers so much to its students and to the community. While a student, I learned many things that proved to be valuable to me as a STEM professional. I honed my skills as a critical thinker. I picked up tools like the scientific method that served me well in my profession. And since, against the advice of many, I did an experimental dissertation, I also learned some trade skills that I hadn't anticipated, like wiring and soldering, and yes, plumbing, and operating machine tools. And those skills have been very handy as my husband and I bought and maintained and sold many houses over the years. I also became proficient in statistical mechanics and electrochemical engineering, and of course, molecular thermodynamics. All those things seem very important to me, but truthfully, I can stand here today and say I never used any of it after I left the campus. Sorry, Professor Newman. Sorry, Professor Prausnitz. However, there were other valuable things that I learned that were not directly related to the curriculum in my particular area of research. These other things were just as important to my success post-Berkeley, and they are even more critically important lessons when I look at the world we live in today. The last few years have been challenging for all of us. Many, if not most of you, started your tenure here in the middle of the COVID pandemic. In addition, you have witnessed the impact of climate change on the world population, as well as here in Northern California. You have participated in debates on social and economic issues in the United States, like diversity, equity, and inclusion, reproductive rights, homelessness, and immigration. I would say that we live in a world today where we have an infinite number of opportunities to bring technology to bear on tough problems. As scientists and engineers, we can and should view these challenges a little differently than the average person, because you see, you can actually do your own research. Through your experiences here, you've learned how to think critically, problem solve, and bring to bear the laws of physics. All important skills. But there are three other key lessons that I learned as a student here that have stood me well throughout the last 40 years, and even more so in the last 5 years. The first of these is the value of diversity. And let's use that with maybe a little d. In fact, I was a diversity candidate, but probably not for my time here at Berkeley, but probably not for the reason you think. As the dean pointed out, there weren't very many women in chemical engineering, and arguably, the number of women is still low in a male-dominated STEM world. But that was not my diversity. I came from a relatively small non-research-oriented undergraduate school called New Jersey Institute of Technology, a school which some of my fellow classmates from, let's just say, more elite undergraduate schools called a blue-collar engineering school, and I wear it proudly. See, the Department of Chemical Engineering in the 1970s did have a diversity program. It focused on building their graduate student cohorts from a diverse background of undergraduate colleges. and almost always had at least one graduate in a cohort from a blue-collar engineering school. I witnessed the wisdom of this approach as I saw my classmates and I take on many different challenges and debates where the strength of our diversity paid off in innovation and creativity. I witnessed the strength of a team that consisted of engineers and even some scientists who could solve Maxwell's equations and other engineers that could design a vacuum pump. My experience went beyond the value for research and technical engagement as well, however. For the first time in my life, I got to experience dim sum in Chinatown in Oakland with a classmate from Hong Kong. Growing up in North Jersey, where there was a pizza joint on every corner, I had never had the opportunity to experience a meal where I had no idea what I was eating. I couldn't even understand what my host was ordering. And then on the weekends, I would stroll the campus and listen to the African musicians play, a far cry from my days growing up listening to Bruce Springsteen. So my growth as a person, as a citizen in the world, was vastly accelerated by my stay at Berkeley. I learned the value of a diverse team and the richness of a lifestyle that was exposed to different cultures, and I applied those lessons in that value of diversity as I built teams throughout my professional career in the Air Force and in my engagements with my communities as a soccer mom and a band parent. The second important lesson I learned was respect for the power and the fragility of our environment. How can you look out over that bay with the mountain backdrop and not appreciate the tremendous beauty of the world we live in? And then observe the tremendous accomplishments of technology. How about the first time you experienced those trembles from an earthquake, if you're not from this area? Pretty unnerving, huh? I can still recall the first time my walk-in hood at Gilman Hall started to sway while I was inside it. But then I observed the tremendous accomplishments of earthquake engineering that enables so many millions of people to live here in Northern California safely. And if you don't understand the value of earthquake engineering, think about Taiwan versus Iran and the major earthquakes we've seen in the last couple of years. How can you help but value the understanding of the interaction between our environment and our science and engineering accomplishments? Whether dangerous effects on our lives due to climate change is caused by something we did or is a fact of nature, we can and should apply technology skills to adjust that balance between human living and nature. Throughout our history in this country, we have explored new land and changed the environment by our actions. History tells us about the dust bowls of the plain states as we removed all vegetation. And the need to find that balance between nature and man is a continual journey for us. You see, we are not boxing match opponents with nature. We are ballroom dance partners who need to respect and help each other. In this century, we as scientists and engineers have a responsibility to take the lead in reestablishing that balance. We can't go back. We can only go forward. And then finally, the third and probably most important lesson I learned was from Professor John Newman. I recall the advice he gave me when I was beginning to write my first publication. See, I was struggling to explain my experimental data. And he told me, whatever you do, always preserve the integrity of your work. Never sacrifice your credibility for the sake of a publication or publicity, because once you lose it, you can never get it back. As we now live in a world where we can espouse our opinions and the results of our research totally unfiltered by reviewers and editors, social media provides unfettered access to everyone. But we need to remember Professor Newman's words and make sure that we are not so enamored with how many likes or followers we can collect. Our measure of success is not how many people follow us, but in the impact of our work on making the world a better place through technology. In sum, when you leave here today, I need to warn you, the Alumni Association will be getting in contact with you tomorrow for your first donation. When you leave here today, you are bringing with you a wealth of experience that will make you a better citizen of the world. Appreciate the lessons you've learned from your professors and the work that you have done as a technologist. But don't forget the other treasures that the Berkeley experience provides. Embrace the benefits and richness of diversity. Practice dancing with nature. And preserve, above all else, your integrity. Now, go out there and make the world a better place for my grandchildren. Thank you for letting me participate today.
Thank you, Ellen. Well, last night, the college held its first ever separate honors and awards ceremony, recognizing some of our most outstanding graduates of 2024. And let me say that in general, this year's graduating class of the College of Chemistry undergraduates continue to demonstrate Berkeley's excellence by virtue of the breadth and number of awards received, honors bestowed, job opportunities offered, and admission to the top graduate programs in the world. In short, our students continue to excel, inspire, and amaze. Over 70 students received honors at last night's ceremony. The eligibility requirements for honors are as follows. Students graduating with a 3.818 GPA receive the rank of honors. Students with a 3.915 GPA receive high honors. And students with a 3.990 GPA receive highest honors. You can tell at the College of Chemistry we like significant figures. I would like to ask all of our graduates who have received the distinction of honors, high honors, and highest honors to stand and be recognized for your extraordinary work and achievement. You will see a listing of those awards, which were also presented at our ceremony last night. So I would now like to ask that those graduates listed in the program now stand and be recognized. Thank you. And please be seated, and congratulations to all of our student awardees. I would now like to take a moment to recognize a few of our distinguished faculty members. The Departmental Teaching Award is presented to a faculty member in each department in recognition of their exceptional teaching. The award is based upon nominations submitted by our graduating students. Recipients of this year's awards are Richmond Sarpong in chemistry and Joelle Frechette Chemical and Biomolecular Engineering. And finally, the Donald Sterling Noyce Prize for Excellence in Undergraduate Teaching is given annually to a faculty member in the physical sciences, not just chemistry, who has demonstrated unusual success in undergraduate education, including work in the area of curricular development. This year's Noyce Prize recipient is Chemical and Biomolecular Engineering Professor Kranthi Mandadapu. Okay, well now we have come to the main purpose of the day, and that is the presentation of degrees. Anyone out there interested in receiving a degree? You're here, so why not? So I now call upon Anne Berenger, Professor of Chemistry, to announce the BS degree recipients in chemistry. Will the degree candidates please rise and line up at the edge of the stage?
Tavio Arias. Kiara Ning. Dorian Bagney. Hangi Stella Ban. Patrick Barr. Andy Calixtro Lopez. Jonas Joseph Castillo. Nicholas Chan. Brianna Fitzgerald. Jenny Fetzer. Mason Earhart. Irma Guadalupe Duran. Sean Dunbar, Valeria Coria Castaño, Tawny Day, Hannah Cho, Wei-Shan Huin, Sarah Grace Hoyle, Ernest Hermosillo, Yifan Guo, Raul Omar Gomez, Ankita Ghosh, Tong Li, Adilman Flores Bonilla, Mumtaz Gababa, Xander Fleming, Parnika Kant, Hamail Khan, Diane Kim, Brian Junso Kim, Henry Lamb, Jimmy Lau, Anthony Lara, Ian Lee, Jacob Lehman, Helen Lee, Selena Wenjin Liu, Chane Eric Liu, David L. Wu, Ziang Ma, Amani Suman Malik, Rigney Miller, Swathi Natarajan, George Paoletti, Inji Park, Kaifei Shu, Hamlin Wu, Emmanuel Ruvalcaba, Panos Reskos, Suraj Rao, Lucy Tran, Catherine Lee, Madison Pearson, Morgan Charles Fennig, Alan Pham, Anthea Pham, Yan Hao Tian, Angel Zhang, Sabrina Carter, BA in chemistry. I don't announce it, but he announces it. Keep reading. Okay. Tyler Liu, Chenin So,
Okay, this is the best part. By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Bachelor of Science in Chemistry. Professor Behringer will now read the names of the BA degree recipients in chemistry. So would the degree recipients candidates please rise and line up at the edge of the stage. Oh, we did the DAs? Got it. Turns out that I'm remiss. By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Bachelor of Arts in Chemistry. We covered them both. Now, Professor Behringer will announce the names of the BS degree recipients in chemical biology. So will the degree candidates please rise and, well, you know what to do.
Edward Chikichi. Aurora Chakowski. Jordan Chastain. Joseph Chung. Belinda Chen. Jilin Dong. Michelle Evelyn Flores. Alexander Garcia. Nelson Gaillard. Kylie Gao. Liam Landon. Samantha Brewer. Gianna Segali. Lu Guo. Salvatore Vallejo. Maya Hirano. Justin Kaito Church. Isaac Garcia. Ruby Hai Ho. Sasha Levy. Anthony Lan. Maria Trinidad Castro Duran. Christopher Alog. Nare Agakanyan Garibi. Wakesy Hu. Junyi Xu. Yumen Wu. Chia K. Song. Andrew Dye. Ryan Tran. Jacob Christopher Hasurin. Tui An Le. Claire Lee. Shuelan Lin. Heidi Jin. Jiayi Lu. Siyu Yang. Jayu Lena Wong. Jofina Natina. Akane Osa. Hannah Kang. Jin Tan. Ying Jung Jenny Wu. Arzin Tobani. Andrew Stephen Pugliese. Zev Taliasin Armour Garb. Vijay Prathigudupu. Grant Evan Rezki. Anish Somani. Halime Yilmaz. Vito Resnick. Ruthul Mungul. Brian Wen. Benjamin Le. Jatin Singh. Consuelo Ugarte Montero. Shayan Yusefian. Ryan Tagizade. Avery Yang. Kyle Zhao. Reihua Young. Xiaoying Zhang.
By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Bachelor of Science in Chemical Biology. I now call upon Karthik Shekhar, Professor of Chemical and Biomolecular Engineering, to announce the BS degree recipients in Chemical Engineering. Will the degree candidates please rise and line up at the edge of the stage?
Daniel Chavez. Dior Chen. Catherine Creer. Jizang Li. Jerry Ho. Jason Chu. Austin Culp. Kiana Harris. Gabriela Gonzalez Aguilar. Juan Carlos Mondragon. Jordan Rasaya. Alex Rosales. Brittany Ibarra. Andre Garcia. Andrew Huynh. Jeremy Gong. Aaron Feldman. Tomas Eleta. Beryl Gir. Andrew Tran. Anya Zoroaster. Ravtej Kaur. Brianna Yang. Gehui Hao. Braden Stone. Zamiria Johnson. Lucy Gleason. Amy Wong. Christopher Garcia. Alexander Hartono. Ellie Kim. Dakota Frost. Carlos Ramirez. Esther Uwandu. Prisha Davda. Ala Al-Khamiz. Victoria Rodriguez. Maha Salut. Jenna Tamar Kira. Quinn Tran. Anish Chigurupati. Joseph Adari. Pragnay Nevatia. Siddhant Chinakotla. Pranav Ramachandra. Sunshine Tanpipat. Justin Gardner. Arya Madan. Raphael Lee. Sai Munagawalasa. Talisa Tucker. Charita Kaki. Sejal Gupta Krishnan. Tara Dubridge. Abigail Newen. Keelan Hunt. Veronica Arriaga. Camila Lozano Avalos. Ian Tang. Anthony Hon. Henry Shi. Ryan Redmond.
Let's go, Ryan.
Yahor Wazmitsel. On Nguyen. Jason Procker. Samantha Noriega. Autumn Neal. Kritika Natarajan. Nikita Sridhar. Lucio Yang. Simin Chan. Ashley Chon. Kylie Chung. Timothy Unsulangi. Pancham Pawan. Jay Casper. Mia Salgado. Sophia Baker. Jackson Feller. Jason Shin. Lonnie Hollingsworth. J.U. Wong. Beatrice Janice Ongawan. Brian Chen. Henry Chen. Kwan Mai. Justin Rader. Justin Yee. Jasmine Chan. Carla Andre Dones. Nathan Wong. John Wallace Jr. Benjamin Semelovic. Brian Schott.
By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Bachelor of Science in Chemical Engineering. Now, for the Professional Master's degree in the Product Development Program, Dr. Keith Alexander will read the names of the MS degree recipients in Chemical Engineering Product Development Program, and Chair Brian McCloskey will join me in congratulating the recipients.
Completely out of order. Okay. There you go. All right. Okay. It's okay. All right. So behind the line. There you go. Perfect. Joel Claw Whitaker. Thank you. Ki Yi Yao. Ray June. Halloween Shin. Omari Jones. Pranav Guru Prasad. Jana Lynn Fernandez. Andrew Chang. Oops. Kuanfu Chen. Swampnil Knighton Bavsar. Okay, let's go here. Wenjing Gao. Li Pei. John Shahin. Michelle Singer. Daniela Paredes Rubles. Nathan Dominique. Xuan Ying. Shivanshu Mishra. Excellent, thank you. Siddhartha Mandeva. TNC Lee. Premanad Sivu Kumar. Behind the yellow one. There you go. Yash Tawade. Parth Thakkar. Utkarsh T. Wari. Jofun Yaputra. Sin Yu Jang.
By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Master of Science in Product Development. And now for the professional master's degree in the bioprocess engineering program, Executive Director Chazen Ryder will read the names of the MS degree recipients in chemical engineering, bioprocess engineering program. And Chair Brian McCloskey will join me in congratulating the recipients.
Noth Ibrahim Al-Hazmi. Vanessa Chen. Jose Luis Correa. Caleb Jen. Anna Kirianowitz. Christian Peter Linfoot. Nicolas Martinez. Wen Tui Quinn Zhao. Si Zhou. Alexander Mark Schumacher. Jacob Aaron Thompson. Wen Elise Belzi. Aparna Vikram. Hu Chi Zhou.
There we are. By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Master of Science in Bioprocess Engineering. Now, for the Professional Master's degree in Molecular Science and Software Engineering, Professor Teresa Head Gordon will read the names of the MS degree recipients in the Molecular Science and Software Engineering program, and Chair Dean Tost of the Chemistry Department will join me in congratulating the recipients.
Okay. You ready? Okay. Giovanni Battista Altari. Joshua Blomgren. Sean Bray. Chia Tiffany Chow. Parker Elizabeth Fraun. Elizabeth Gilson. Sarah Gomez. David Huang. Changyi Feng. Jeffrey Jacob. Jeffy. Amar Jelani. Karis Liao. Destiny Maldonado. Oluko Rede Ungadela. Trevor Oldham. Radhika Sahai. Samuel Joseph Wallenberg.
By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Master of Molecular Science and Software Engineering. Now, for the Master of Science in Chemistry, you read that. Chair Dean Tost will read the names of the MS degree recipients in chemistry.
All right, let's find that. What are they?
they on here somewhere? Calais Cronin. Sure. Abigail Medlin. Diego Novoa.
By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Master of Science in Chemistry. I now call upon Chair Tost again, who will read the names and thesis titles of the PhD degree recipients in chemistry. Hold that thought.
That's what I thought.
Back to Brian. Now for the master's degree in chemical engineering. I know this one. Chair Brian McCloskey will read the names of the MS degree recipients in chemical engineering. Haley Boyer. By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Master of Science in Chemical Engineering. Now it's his turn again. I call upon Chair Tost, who will read the names and thesis titles of the PhD degree recipients in chemistry. Each student will be hooded by their faculty research advisor, or in their absence, Dean Arnold or a colleague.
I shook his first. You ready, man? All right. William Beatrice. The thermalization and transport of hyperpolarized nuclear spins, thesis advisor, Ajit Choi. Now turn around. There you go. Rafaela Mendez Brin, investigation and photophysics of thin films composed of quantum dots and rare earth doped ferroelectric Proscovites. Paul Alivisatos and Murthy Ramesh, thesis advisors fitted by John Arnold. Xishan Wang, towards automated nanoscale visualization, artificial intelligence for the autonomous electron microscopy, thesis advisor Paul Alivisatos, being hooded by Professor Arnold. Ian Joseph Brackbill, structure and reactivity of group 14 elements, heavy element Lewis pairs, hooded by his thesis advisor, John Arnold. Christopher Shi-Yu Yi, hydride-supported actinide transition metal complexes, being hooded by his thesis advisor, Professor John Arnold. Thank you. Samra Kuzmerovich, tailoring spin and charge order of two-dimensional crystals through intercalation and heterostructure design, being hooded by her thesis advisor, Kwabna Bediako. Gigi Kwong, the magnetism study of two-dimensional van der Waals materials, being hooded by her thesis advisor, Kwabna Bediako. Madeline Van Winkle, mapping structure deformations in warm materials using diffraction-based electron microscopy, hooded by her thesis advisor, Kwabna Bediako. Kai D. Zhang, tunable electrochemistry to Moir lattice engineering, hooded by his thesis advisor, Kwabna Bediako. Aiden Takakiyo Pizatsky. I'm going to do that one again. Aiden Takakiyo Pizatsky, tandem sensing labeling approaches for probing transition metal biology, hooded by his thesis advisor, Chris Chang. Elijah Noam Allen Kissman, mechanistic studies and engineering of radical amino acid halogenases, hooded by his thesis advisor, Michelle Chang. Max Bernstein Sosa, biosynthesis of amino acid-derived natural products, halogenation as a metabolic entry point into microbial secondary metabolism, hooded by his thesis advisor, Michelle Chang. Michael Cronin-Doherty, design and synthesis of semiconducting and magnetic graphene nanoribbons, hooded by his thesis advisor, Felix Fischer. Chinho Ethan Wen, engineering electronic and spin properties into graphene nanoribbons, hooded by his thesis advisor, Felix Fischer. Shui Ji Yang, understanding design principles of the photosystem 2 supercomplex using ultrafast spectroscopy and simulation methods, hooded by his thesis advisor, Professor Graham Fleming. Paul Huang, targeted drug delivery strategies for glioblastoma therapy, hooded by his thesis advisor, Professor Matthew Francis. Paige Bistano, engineering virus-like particles for the efficient delivery of therapeutics, hooded by her advisor, Professor Matt Francis. Connie Deborah Robinson, analyzing black box optimizers for saddle point discovery and molecular dynamics, hooded by her forgetful thesis advisor, Matt Francis. Ziad Shafi, lanthanide complexes featuring terminal oxo and methyl ligands, how covalency, redox, and sterics impact stability of lanthanide bonding. Thesis advisor John Gibson, hooded by Professor Arnold. Leo Mark Hammerlink, Spatiotemporal Investigations of Energy Transfer in Natural and Artificial Light Harvesting Systems, hooded by his thesis advisor, Naomi Ginsburg. Lapjung Nugent Liu, Biophysics of Signaling Protein Condensates of Supported Lipid Membranes, thesis advisor Jay Groves, hooded by Professor John Arnold. Brittany Lynn Stinger, Investigating Protein Condensations in Ligand-Mediated Cell Signaling, thesis advisor Jay Groves, being hooded by Professor John Arnold. Jake Shee, Synthesis of Sustainable Commodity Materials, thesis advisor John Hartwig, being hooded by me. Isaac Yu, Practical Borylation of alkyl-CH bonds with iridium catalyst, methodology and mechanism, thesis advisor John Arnold, being hooded by me. No, by John Hartwig, sorry. All right. Xingyi Guan, Design Machine Learning Enhanced Tools and Physics-Based Techniques for Force Field and Electrostatic Models, thesis advisor Theresa Head Gordon. Alexander Michael Profit, Multi-Phase Chemical Kinetics in Microdroplets, Mass Transport and Reactivity at the Air-Water Interface, thesis advisor Kevin Wilson, being hooded by Professor John Arnold. Michelle Catherine Anderson, the Commodore in Quantum Systems for Transition States, Reaction Mechanisms, and Coherent Control, being hooded by our thesis advisor, David Limmer. Lucas Spetzer, Total Synthesis of plus racinifer toxin and the studies towards the total synthesis of 1-alkyl dapnanes, thesis advisor Tom Emoni, being hooded by me. Where was I? All right. Kayla Jean Belovic, Computational and Synthetic Exploration of Novel Fluorophores for Advanced Indicator Development, thesis advisor Evan Millen, who's hooding her. Julia Grace Martin, Imaging Reversal Mitochondrial Membrane Potential using an enzymatically unchanged rhodamine voltage reporter, being hooded by her thesis advisor Evan Miller. We all do, actually. Jack Thomas McCann, A Physical Organic Approach Towards Fluorescent Probes of Biological Imaging, hooded by his thesis advisor, Evan Miller. Deshka Lin Neal, Genetically Targeting Fluorogenic Voltage-Sensitive Dyes via Enzymatic Uncaging, hooded by our thesis advisor, Evan Miller. Steve Robert Sarek, Investigation of Small Molecule Dynamics using Fast Beam Photofragment Spectroscopy and flat liquid jet scattering. Thesis advisor Dan Newmark, hooded by Professor Arnold. Margot Lee Myers, leveraging chemoproteomic platforms to expand the scope of induced proximity-based modalities. Thesis advisor Dan Omura, being headed by me. Hooded. Ethan Shigeru Toriki, rational chemical design of molecular glue degraders. Thesis advisor Dan Nomura, being hooded by me. DGU, understanding engineering of biosynthesis of thermal alkene and alkyne containing natural products. Thesis advisor, Professors Ryder and Zhang. That's you. Being hooded by her advisor, Wenjun Zhang. Kristen Elise Gardner, diversification of two pyrones into carbo and heterocyclic ring scaffolds, hooded by her thesis advisor, Professor Richmond Sarpan. Karun Goyal, exploration of spirocyclic topology, reaction discovery en route to the total synthesis of uracilinoids A and B. Hooded by his thesis advisor, Richmond Sarpan. Jack Hayward Cook, synthetic studies towards the amphidicholin family of total synthesis of pupukinin natural products using the Contra biosynthetic strategy, hooded by his thesis advisor, Professor Richmond Sarpan. Frankie Bernal, spectroscopy of interfaces, liquids, droplets, and solids. Thesis advisor, Professor Richard Sakely, hooded by Professor Arnold. Erica Joan Reif, investigating buried interfaces in liquid carbon by the second harmonic scattering and X-ray scattering. Thesis advisor, Professor Sakely, hooded by Professor John Arnold. Neville Navzir Dadina, small molecule tools for advanced imaging, hooded by his thesis advisor, Professor Lana Shepards. Isaac Jacob Knudsen, chemical and ribosomal synthesis of peptide macrocycles and embedded heterocycles, hooded by his thesis advisor, Professor Lana Shepards. Wait a second. This is backwards. O'Cameron, Verdine, Swanson, expanding the substrate scope of amino acid tRNA synthesases for site-specific incorporation of non-amino acid monomers into proteins, hooded by his thesis advisor, Alana Shepards. Tiaporn Thang Pradak Kun, investigating structure and interactions of RNA and synthetic biology, insights into the minimal peptidyltransferase center of T-box riboswitch, hooded by her thesis advisor, Professor Lana Shepards. Richard Lee Thornton, experimental considerations and theoretical treatment of time-resolved polarization spectroscopy, thesis advisor, Daniel Slaughter, hooded by Professor John Arnold. These are getting tough now. All right. Hoi Ting, Katie Chung, symmetry engineering of multi-charge stabilization of 2 electron catholites. I'm the thesis advisor, and I will happily hood Katie. All right, doesn't get any easier. All right, Annika Carolyn Score Page, a physical organic approach to rational design of chemical biology, development of acyl, silane, and oxazirine platforms for chemoproteomic profiling. I'm the thesis advisor, and I will happily hood Annika. All right. Kei Tianlu Shi. Non-covalent interactions, structure-activity relationships, and supermolecular host-guest chemistry and science and society. I'm the thesis advisor, and Professor Berenger will join me in hooding Kei. Elizabeth Dawn Hefner, expanding reactivity understanding of asymmetric catalysis with nanopure supermolecular hosts, jointly advised by myself and Professor Kane Raymond, and I will gladly hood Elizabeth. Okay. Mira Don Liu, specialized metabolites and microbial adaptations in post-fire soils, being hooded by our thesis advisor, Matthew Traxler. B. Win Johnny Ko, input-output formulations of quantum nonlinear spectroscopy, thesis advisor, Professor Brigitte Whaley, being hooded by Professor John Arnold. Alexander Akira Choi, single molecule and super resolution microscopy of fast intercellular diffusion, being hooded by his thesis advisor, Professor Kushu. Brett Alexander Unger, super resolution microscopy and single molecule diffusivity mapping, application in cell biology and biophysics, hooded by his thesis advisor, Professor Kushu. Priscilla Fiona Peters, multi-scale characterization of self-assembly, structure, and properties of organic, inorganic nanomaterials, hooded by her thesis advisor, Professor Ting Shu. Oscar Yufan Chen, design and synthesis of metal organic frameworks and covalent organic frameworks for the carbon dioxide capture direct from air, thesis advisor, Professor Omar Yagi, hooded by Professor John Arnold. Ephraim Neumann, molecularly woven frameworks as templates for polymer entanglement, thesis advisor, Professor Omar Yagi, hooded by Professor John Arnold. Xiling Zhang, Enhanced Atmospheric Water Harvesting and Metal Organic Frameworks, thesis advisor Omar Yagi, being hooded by Professor John Arnold. I guess he's not here. Is that, no, he's not here. Okay. It's not him. All right. Chung Kwan, Andy Lin, thesis advisor Omar Yagi, investigating, Peidong Yang, all right, Peidong Yang, that's investigating nuisances and optical properties of low-dimensional halide perovskite semiconductors.
By virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Doctor of Philosophy in Chemistry. Chair McCloskey will now read the names and thesis titles of the PhD degree recipients in chemical engineering. All right.
Darby Hickson, characterization of ion transport and liquid electrolytes by combining electrochemical methods and electrophoretic NMR. Hooded by PhD advisor Natasha Balsara. Morgan Seidler, atomic scale cryogenic electron microscopy of synthetic polymers, hooded by PhD advisor Natasha Balsara. Justin Bowie, a continuum model of bipolar membranes from fundamental physics to application in energy conversion and storage, PhD, hooded by PhD advisor Alex Bell. Douglas Chamberlain Miller, tRNA deacylase directed discovery of biosynthetic pathways, hooded by PhD advisor Michelle Cheng. Yu Fu, particle adsorption at fluid interfaces using microtensiometry, hooded by PhD advisor Joelle Frechette. Emily Carvalho, brain mimetic material design of hyaluronic acid hydrogels to study glioblastoma invasion, hooded by PhD advisor Sanjay Kumar. Erica Alexandria Ding, sequence conformation relationships in nanofilament tail domains and roles of neurofilament proteins and axon mechanical properties, hooded by PhD advisor Sanjay Kumar. Francis Shane Castaneda Ledesma. Covalent conjugation of active proteins to single-wall carbon nanotubes, PhD advisor Marquita Landry, hooded by John Arnold. Matthew Dodds, Direct air capture with amine functionalized metal organic frameworks, PhD advisor Jeff Long, hooded by John Arnold. Ahmad Al-Qadri, osmosis permeability and the mechanics of biological membranes, hooded by PhD advisor Kranti Manandapu. Trisha Singh, improving low temperature performance of lithium-ion batteries, hooded by me, Brian McCloskey. Kimberly Jing Ying Chan, learning base control on the edge for cold plasma devices. PhD advisor Ali Mesbah, hooded by John Arnold. Victor Von Miller, renewable fertilizer by low temperature plasma enabled manure upcycling. PhD advisor Ali Mesbah, hooded by John Arnold. Katong Shou, simulation machine learning enhanced study of non-thermal plasma assisted processes. PhD advisor Ali Mesbah, hooded by John Arnold. Anna Carnero, directed evolution for discovery of novel AAV variants and addressing its pitfalls, hooded by PhD advisor Dave Schaefer. Salwan Yunis Putris, single-cell molecular profiling of cell type, development in mouse, visual, and somatosensory cortex, hooded by PhD advisor Karthik Chekar. Joshua Hahn, retinal transcriptomics across evolution and in disease, hooded by PhD advisor Karthik Chekar. Nikhil Agrawal, modified Gaussian renormalized fluctuation theory for electrolytes at interfaces. PhD advisor Rui Wang, hooded by John Arnold.
Well, by virtue of the authority vested in me by the President and the Chancellor, I grant you the degree of Doctor of Philosophy in Chemical Engineering. Well, I would now like to close this ceremony with just a few brief remarks about this wonderful occasion. I extend my warmest congratulations to our graduates and welcome you to permanent membership in the College of Chemistry community as alumni. It has been my honor to have led this commencement for the last 11 years. Thank you. Thank you, thank you. My colleagues and I wish you the very best in your careers and lives and hope that you will all stay in touch with us and keep us informed of your future accomplishments. Second, I would like to extend my sincere thanks to the families and friends of our graduates who are in the audience this afternoon. The successes of the graduates sitting before us would not have been possible without your sustained love and support. All of you have played a vitally important role in bringing us here today. My colleagues and I applaud you and your efforts and share your pride in the accomplishments of these very impressive graduates. Finally, graduating from the College of Chemistry carries with it a responsibility that continues after you leave Berkeley. Now, more than ever, we depend on our alumni to continue to support the teaching and research carried out here. And we hope that you will remember us as you move forward into your future careers. But don't worry too much about that. Remember that alumni association that Ellen mentioned in her speech? They'll be in touch. So this brings us to the end of our ceremony. The procession of faculty and graduates will first leave in the same order in which we entered the auditorium. So I shall leave you with this. Former College of Chemistry Dean Glenn Seaborg, who also happened to be our second chancellor, a Nobel laureate, and advisor to 10 US presidents, once noted that many people believe that, quote, science should move us forward to a utopian, problemless, riskless society. This is a false notion. We live, and always will live, in a dynamic situation amid problems whose solutions will breed other problems. There always will be dangers, risks, and increasing responsibilities that will drive us towards a new level of excellence in all we do or try to achieve. Well, it is now your time, College of Chemistry graduates, to drive toward a new level of excellence in all you strive to achieve. Congratulations, best of luck to you all, and as always, well, wait a minute. This is the last time I'm going to get to do this. So I would really appreciate it if you could join me on the count of 3 in a rousing holler of Go Bears. You think we can do that? All right. 1, 2, 3. Go Bears!